Good day everyone! In this video, we will be tackling reaction stoichiometry. Reaction stoichiometry describes the quantitative relationships among substances as they undergo chemical changes. We have to take these steps to guide our work. For our problem, iron oxide is a result of the reaction of iron with oxygen in air. So solve the following. Number 1. What number of moles of iron reacts with 15.25 mole of oxygen in air? The first thing we need to do is to write a balanced chemical equation. We have iron reacts with oxygen, which is diatomic, forming O2. Iron oxide is Fe2O3. So now we need to balance it. We have 2 oxygen on the left and 3 oxygen on the right. Let's place a coefficient of 3 in front of O2. So now we have 6 oxygen atoms, which means we need to put 2 in front of iron oxide. The oxygen atoms of both sides are now equal, but the iron wasn't, so let us put 4 in front of it. Now we have a balanced equation. You can derive mole relationships between reactants, between products, and between reactants and products where 4 mole of iron is equal to 3 mole of oxygen and 4 mole of iron is equal to 2 mole of iron oxide and 3 mole of oxygen is equal to 2 mole of iron oxide. Moving on to the second step, we are given 15.25 moles of oxygen and need to convert it to moles of iron. And now we have to solve it. We have to use the mole of ratio to change the substance. The mole ratio between oxygen and iron based on the balance equation is 4 to 3. So 4 moles of iron reacts with 3 moles of oxygen. Remember, you have to put the same unit opposite to each other so that you can cancel. So let's put 3 moles of oxygen at the bottom and 4 moles of iron at the top. So the answer is going to be 15.25 times 4 and divided by 3, which is 20.33 moles of iron. Number 2. What mass of iron is required to react with 15.25 mole of oxygen? Similar to the first problem, we begin by converting the moles of oxygen to moles of iron. However, this time, we also need to convert moles of iron to grams. So, we have 15.25 moles times 4 moles of iron over 3 moles of oxygen. Next, to convert moles to grams, we use the molar mass of iron, which is 55.85 grams per mole. Now, we would get 1,136 grams of iron. Number 3. What mass of oxygen will react with the amount of iron in problem number 2? The mass we got on number 2 is 1,136 grams of iron, and we need to convert it to the mass of oxygen. First, we have to convert grams to mole. Do not forget to put the same unit opposite to each other so that you can cancel it. After that, we have to change mole of iron to mole of oxygen, which according to mole relationships, there are 3 moles of oxygen that react with 4 moles of iron. Lastly, we have to convert mole to grams. We would get 488.2 grams of oxygen. We also need to ensure that our final answers adhere to the rules of significant figures based on the provided data. In problem number 1, the lowest significant figure is 4. That's why all our answers must be in 4 significant figures. Moving on, for our problem number 2, limestone CaCO3 dissolves in muriatic acid HCl, forming calcium chloride, carbon dioxide, and water. Firstly, we need to balance the equation. Since we have one hydrogen atom on the left and two on the right, we need to place a coefficient of 2 in front of hydrochloric acid or muriatic acid. Now we have a balanced equation. Now in part A, we are given limestone, CaCO3, and we need to convert it to moles of hydrochloric acid. So we will multiply 7.7 moles of limestone by 2 moles of hydrochloric acid over 1 mole of calcium carbonate. After canceling units, we are left with moles of hydrochloric acid. Therefore, 15.4 moles of hydrochloric acid are required to solve 70.70 mole of calcium carbonate. For part B, we are still given 7.70 moles of limestone. Firstly, we will convert calcium carbonate to water as that's what we are looking for. By the way, calcium carbonate is another term for limestone. The mole ratio between calcium carbonate and water is 1:1. So for each mole of calcium carbonate that reacts, 1 mole of water is produced. Now, we can convert moles of water to grams. The molar mass of water containing 2 hydrogen and 1 oxygen atom is calculated as 2 times 1.01 plus 16, which is equals to 18.02 grams per mole. So we have 7.70 times 1 divided by 1 times 18.02. Therefore, we would get 139 grams of water. Now, we will proceed to limiting reactants. We will be using this when you are given the amounts of two reactants. It is important to identify the limiting reactants since the calculation of the amount of the required substance is based on the amount of the limiting reactant. So moving on to our problem. If 18.0 grams of methane reacts with 50.0 grams of oxygen gas, how many grams of carbon dioxide will be formed? So this is a combustion reaction where methane and oxygen gas produce carbon dioxide and water. Firstly, let's balance the equation. To do that, we simply place a coefficient of 2 in front of water because we have 4 hydrogen atoms on the left side. Similarly, we need to place a coefficient of 2 in front of oxygen. After that, everything else is balanced. Now, we need to identify the limiting reactant since we have 2 reactants. We are given 18.0 grams of methane and 50.0 grams of oxygen. To find the limiting reactant, we need to convert the given masses into moles and calculate the mole of ratio, or calculate the mole ratio. Now we need to identify the limiting reactant since we have two reactants. We are given 18.0 grams of methane and 50.0 grams of oxygen gas. To find the limiting reactant, we need to convert the given masses into moles and calculate the mole ratio. Starting with methane, we use the formula mass divided by the molar mass to obtain the moles. So 18.0 grams divided by 16.05 grams per mole gives us 1.12 moles. So for oxygen, we have 50.0 grams divided by 32 grams per mole, resulting in 1.56 moles. Next, we calculate the mole ratio by dividing the moles by their respective coefficients. For methane, 1.12 moles divided by the coefficient of 1 gives us 1.12. For oxygen, we divide 1.56 moles by the coefficient of 2, resulting in 0.78. As we can see, oxygen gas has the smaller amount, making it our limiting reactant. Now, we can solve for the mass of carbon dioxide. Firstly, we convert moles of our limiting reactant to the moles of carbon dioxide using a ratio of 1 to 2, and then convert moles of carbon dioxide to grams using its smaller mass of 44.01 grams per mole. Therefore, 34.3 grams of carbon dioxide will be formed. Now let's move on to the percent yield. The formula for percent yield is equals to actual yield over theoretical yield times 100. Theoretical yield is the yield calculated by assuming that the reaction goes to the completion, whereas the actual yield is the amount of product that is actually obtained, which is always less than the theoretical yield. For our problem, we are given that 50.00 grams of benzene is placed in a container with 160.0 grams of oxygen gas. After the reaction, 30.00 grams of water were collected. We are asked to determine the theoretical yield and the percent yield. Given the balance equation, we will start by determining the limiting reactant. To do this, we calculate the moles of benzene and oxygen, and then their moles ratio. Dividing the mass of benzene by its molar mass, which is 79.12 grams per mole, and dividing by 2 gives us the moles of benzene. Similarly, dividing the mass of oxygen by its molar mass, 32 grams per mole, and dividing by 15 gives us the mole of oxygen. Since benzene has the smaller amount of moles, it is our limiting reactant. Next, we will compute the theoretical yield. We will start by converting the moles of our limiting reactant, benzene, to the moles of water using the mole ratio from the balance equation, which is 2 to 6. Then we convert moles of water to grams using its molar mass, which is 18.02 grams per mole. This calculation yields a theoretical yield of 34.60 grams of water. Finally, we will calculate the percent yield by substituting the actual and theoretical yields into the formula. So percent yield is equals to 30.00 grams, which is the actual yield, over 34.60 grams, which is the theoretical yield, times 100. This gives us a percent yield of 86.71%. That's it. Thank you and good luck.